Today, we're going to talk about taxonomy management and use in Sanity Studio. And I want to spend most of our time looking at an example of how we set up, use, and query a taxonomy in the studio. But I want to start us off first with just a couple definitions so that we're all on the same page about what I mean when I say taxonomy and talk about terms. So to begin with, a taxonomy is a collection of controlled vocabulary terms organized into a hierarchical structure. Each term in that structure is in one or more parent-child relationships to other terms in that same taxonomy. So we can see with the example that I have on screen here of this foliage color taxonomy, examples of each of these elements of this definition. So the control of vocabulary terms isn't in order to constrain people, although it does do that a little bit, and it's not to go on a power trip, but it's really to control two problems that we see with using standardized language in knowledge management, and that's synonymy and polysemy. So synonymy, of course, is when two terms mean the same things, they're synonyms, and then polysemy is when one term means two different things. And we have examples of that in this taxonomy. So under the dark category, you can see that I've got purple here as a color. Normal color for plants, that's all good. One might also say that a plant could be violet as a color. It's often a synonym that we use for purple. If we have some people saying that this plant is purple and some people saying that it's violet, then we run into a synonymy problem. And it makes querying things and showing UI elements and helping people understand the interface just more difficult. So we control that term and say, we're only going to say purple when we mean that kind of color. Now, there's another reason if we have a plant taxonomy like we have here, that we might do that, and that's that violet is also a kind of plant. So now you've got this whole other level of confusion that hopefully we're avoiding by controlling these terms. So that's the control of synonymy. For polysemy, you can see that in each of these large categories of dark and light, there's blue, and then there's another blue, there's light blue. Now, of course, these are both blues, but one of them is a different kind of blue, and it's a distinction that's important for the kind of knowledge that we're representing here. So to control that polysemy situation, we have blue and a light blue, and we're saying that these are the two terms that we're going to use instead of just calling everything blue, because then it makes it difficult to tell things apart. And that brings us to the second point. For the second part of this definition, that each term is in one or more parent-child relationships. Now, the relationships that I've created here, that each of these colors is either in a dark shade or it's a light shade, is a reflection of the domain of knowledge that I'm trying to capture with this taxonomy. So a taxonomy of plant colors. And in this case, the purpose of this taxonomy is to clearly group plants into light colors and dark colors. A business purpose for that might be to help people choose contrasting foliage when they're putting together an arrangement of plants. So the taxonomy and the structure isn't an absolute representation of something in the world, but rather it ties back to a business purpose. And the business purpose in this case might be, so the example we're going to look at today would be a plant finder tool where I want to say that if someone is shopping or selecting a bunch of plants and they have a whole bunch of dark plants, I might want to recommend to them that they choose a light plant to go in that collection as well, so that there's some contrast in their planting and some contrast in their gardening, because that tends to make for better planting selections. So this gives us some simple definitions of vocabulary control, and it also gives us an example of the first use of a taxonomy, and that is the recommendation of items, in this case, plants. So recommendation is where we systematically relate topics to generate recommendations for content and products based on a current selection or browsing history. And in the example we just saw, I might recommend to someone, hey, you probably want a light colored plant in this sort of doom garden you're putting together to create a little bit of contrast. Another use for taxonomy is in supporting search. So taxonomies help us associate related and alternate terms in order to augment and add to search indexes. So for example, parent terms, synonyms, or misspellings. And we saw an example in that little taxonomy that I showed right at the beginning, where we have violet is a synonym of purple, and I might add that to my search index so that if someone is clearly looking for the color of a plant and they say, show me all the violet colored plants, I can return the purple ones instead of showing them all the violets. Another use of taxonomy is to support browsing. And when many people see a taxonomy hierarchy, like the one that I just showed, they think, oh, well, that could be global nav or secondary navigation. You can use taxonomy for that, but it's much more common for managing facets. And facets are those fine-grained controls that you often see on websites like Amazon or REI. Lots of e-commerce sites use facets, and other sites as well. In the plant taxonomy, we might, for example, have a facet for colors. So someone can select the different colors they want to see of a set of plants. You might have another facet for climate. So select a temperature range that is consistent with the area that you live in or where you're planting the plants. And then we might have a third one, say, for animal habitat. We can also use taxonomies for analysis. So we can group and aggregate content by topic and category, or really whatever we define in our taxonomy, in order to make more sense of the kind of data that we get from something like Google Analytics. And then finally, taxonomies provide the groundwork for inference. And inference is the process of making implicit knowledge explicit. It surfaces new knowledge from existing information by exploiting the context provided by taxonomies and, in more complex instances, ontologies. And this context is the model of our domain. It's the knowledge model that we're building into the taxonomy. And this last point, although I'm not going to get into inference in our short time together today, this last point is important because it has relevance for those of us who build content models. Taxonomy integration allows us to decouple content structure, so in Sanity, our schema types, from content semantics. And those are the meaningful relationships between those types. So let me give you a really simple example. On my consulting website, I have 4 types of content, 4 types of articles, rather: case studies, interviews, methods, and perspectives. These are semantic differences in the kinds of insights articles that I post on my website. In my Sanity instance, I only have 2 structural content types for these articles, which are interviews, methods, and perspectives, and they share some metadata terms, things like date, short description, JSON LD characteristics, and then a body field, because that's the most granular I need to be with this kind of content. Case studies, however, are entirely different. They have a number of different body fields because we have problems we're trying to solve, the client situation, the outcomes that were achieved. So structurally, they're very different. But structurally, there's not that kind of difference between the articles. Semantically, however, I want to be able to tease out those differences. And I want to do that for a business reason. So if someone's on my site and they're looking at a method, I want to be able to show them a perspective. Or if there's a case study on that same topic, I want to be able to show them a case study. Likewise, if they're looking at a perspective, I might want to show them a method that's related to that perspective if there's one that relates to it topically. And the taxonomy allows me to leverage that knowledge model of my domain and what I'm trying to achieve in a way that doesn't tie it to the structure of my schemas because I don't need that for the structure itself. So let's look at an example of how we get this into the studio, how we can get it into our content types, tag those content types, and then query that data in order to do things on the front end. So what you see here is a view of the Sanity Taxonomy Manager plugin, which I wrote and has been available for a couple of years on NPM. And this is the example that we're going to look at today. So our very first step in installing the plugin, of course, is simply to install the plugin. And we do that in the same way that we would install any other plugin. So in our Sanity config, we'll add Taxonomy Manager after installing it and importing it from NPM. And there are a number of options available with Taxonomy Manager. The one I want to focus on today is the base URI. And the base URI is used for new concepts and new concept schemes to set a universal resource identifier. So this provides a unique and portable namespace for the taxonomies you create. The reason that Taxonomy Manager includes a base URI in addition to Sanity's document ID is so that your taxonomies are portable across data sets. So if you have a dev, a staging, and a production data set, data set, you want to refer to the same taxonomy terms, and also so that your taxonomies are portable across projects. Ideally, if you have related projects that rely on the same kinds of relationships and the same kinds of terms, you're using the same taxonomy to manage them, even if it's in different instances of your data set. So once we install the Taxonomy Manager plugin, we'll see that we have a new tab in your Studio, a taxonomy tab that has concept schemes and concepts. And those are the two content types that come with the Taxonomy Manager plugin. And here you'll see that I've pre-populated a scheme of habitat, so keeping with our plant theme. And this scheme is used to describe the animal habitat provided by specific plants. And you'll see that we have a very simple hierarchy of bees, birds, and butterflies with a couple of child terms under different types of birds. Now, if I want to add to this taxonomy, I will set it in edit mode. And this is just to keep people from, when they're browsing the taxonomy, making changes that they don't intend. And then I'll add another bird here. So if I add a new concept, I'm going to add juncos. And I'll publish that term, and I'll see that it's now in my hierarchy. Now you also see that I have, obviously on purpose, I've put this term in the wrong spot. A junco is not a type of hummingbird. But I did this in order to demonstrate how to move terms around, because this is one of the frequent questions that I get. This is not a drag and drop interface, and there are a number of reasons for that. The primary one being that this manager does support polyhierarchy, which is having a single term in multiple places. I don't recommend you start there, and that's a subject for a whole nother day. But it does mean that moving terms around means that you actually move the term by editing the term itself. So I've still got my junco concept up here, and I can see that it has broader concepts, and this is how the hierarchy is communicated in SCOS, which is the standard that this tool uses. And I can change that hierarchy simply by adding birds and then removing hummingbirds, because I don't actually want a polyhierarchy here. So I publish that, and there I have my juncos where I want them to be under the birds category. Now, before I leave the screen, I do want to point out that the tree view is a convenience view in order to help managers and users of the taxonomy understand the hierarchy and visualize it. If you have a very large taxonomy, being able to collapse and expand and see where the hierarchy is a useful way to view that. But behind the tree view, this is just a Sanity document. So what you'll find is that you have concepts and top concepts in here, and each of those concepts has a relationship to other concepts in the taxonomy, as we saw in our definition from the beginning. And the tree view is just a way to visualize those in a way that's a little easier to understand. Okay, so we've got a taxonomy in our studio. Let's put it to use. I have a plant content type here, and it's just a plant document that's got a name, a couple fields in it, so very simple. I want to add that animal habitat to my plant document. I want to be able to tag plant documents with a habitat. I'll do that by adding an array field of references. And this is the recommended way to add arrays in Sanity. In case you want to add more than one, you can always limit that to a single reference if you only want one term there. And the type of reference is a SCOS concept. So it's the concept itself that gets referenced. However, we don't want to reference all SCOS concepts, because I might have other taxonomies in this studio, and I don't want to reference colors in my habitat field. Now I have to tell people not to choose a color, so it's just a bad user experience. Luckily, Sanity Taxonomy Manager comes with a scheme filter, and this scheme filter is a pluggable function for filtering to a single SCOS concept scheme. And it takes as a parameter the scheme ID. So this scheme ID, if we come back to our habitat scheme in the editor view, is what's attached to that base URI. And this is why we have the base URI, and why I covered it at the beginning, is this is our stable and consistent, unique identifier across data sets and across projects that says, I'm talking about this scheme in particular. So I will grab that ID, and then when I put that in my scheme ID filter, now I'll be filtering to only terms in the animal habitat taxonomy. I'll disable new terms, and I recommend you do this. You don't really want people adding new taxonomy terms to your taxonomy as they're creating content. That way lies madness. And then the last thing I'll do is I'll add the array hierarchy input field component, or the input component rather. And this is a hierarchy view input component for array fields to help your content authors also visualize the hierarchy that you've created. So when I've got this scheme in my plant document type, I'll come back over to my studio and I'll see that if I open one of those plant documents, and here I've got the lovable contorted filbert, I now have an animal habitat field available to me. I still have the standard Sanity way to add items. So I can add a concept from the standard dropdown, and here I'll see that it's limited to only the terms in that animal habitat. But I also don't see the hierarchy here. So this might be a little more difficult for content authors to use. We also have, because I use the input component, a browse taxonomy tree. And in this case, I see the hierarchy that I created in my taxonomy. And I also see any notes that I've associated with individual terms. And those are added to the terms themselves. So these pop-ups will show definitions, scope notes, and examples by default. So your content authors now have a rich view into both the hierarchy and the definitions and usage guidelines for the terms that you've assembled in your taxonomy. So let's go ahead and tag this with chickadees. I click chickadees. I can see that's been added to my animal habitat. I'll publish that for good measure. So now we have a taxonomy, a managed vocabulary in the studio. I've added it to a content type and I've tagged content. Next step, of course, is to query that content and start to do stuff with this. So I've got a few queries I want to show you today. And the first one is just a very simple, show me all the plants that have the same animal habitat as the current plant that's being listed. Okay, so we'll look for type plant. I'll return the name. And then in the shared habitat key, I'll look for a plant document, which is not a duplicate of the current plant, not very useful, and shares a habitat term with the current plant. And I do that by looking at that habitat array, and that's the field that I just created. I pull all of the refs from that array, and then I pull all of the habitat refs from the parent plant. So the plant for whom we're looking for similar plants. There's some grammar. And then I'll look for the intersection of those two arrays. And when I run that fetch, I'll see that I have my contorted filbert, and then I have a shared habitat with sage. And if we go back over here, we can see that sage also provides a habitat to chickadees. So this is a simple demonstration of how you can use taxonomy terms to return results. Now, the astute viewer is probably saying, well, yeah, Andy, but I could have just tagged both of those with chickadee and written a much simpler query. And you wouldn't be wrong, but you also wouldn't be taking advantage of the knowledge model that we capture in a taxonomy. And that's what I want to show you in the next example. So you remember that our individual birds are children of a parent bird category, and we can actually look up that category tree and start to use the knowledge model we've captured in the taxonomy to return more interesting results. So in a second example, let's list the plants and shared habitat animal, the plants with shared habitat animal categories. So I want to look for sibling terms. Again, I'll list plants, I'll list the names of those plants, and then in shared habitat, in this case, I'm looking for the plant document, which is not duplicate of the current plant, and shares a habitat terms broader term with the current plant. So they share a parent, they're siblings. In this case, I'll use a very similar array intersects, but in this case, I'm looking for the broader term for all of the habitat terms. I'm looking for the parents of all the habitat terms, and I return those to the first array that's compared, and then I do the same thing, make that a little bigger, for the plant that we're comparing against. And then I look for the intersection. So here, if I run this query, I can see that for contorted filbert, we now have a shared habitat in ryegrass and in sage. Now, sage we know is a habitat to chickadees. If we look over at ryegrass, we can see that this is a habitat for hummingbirds. And if I look into my taxonomy tree, of course, these are both birds. So now we've queried for sibling terms. There's one more query that I want to show you, and that is one that's going to use the second taxonomy we have in here, and that is this foliage colors facet. You also see in this taxonomy that there's a hardiness branch of this taxonomy. And this is the zone that plants are appropriate for, rather, the ones that they're happy in, let's say. And this depends on different zones across the US. And this is a way that you might construct facets. So foliage color is a facet, hardiness is a facet. And if it makes sense, I can put those all in the same taxonomy. So if I go back over to my ryegrass, I can see that I have a foliage color associated with ryegrass, and it has the same taxonomy tree. It has been limited to just that branch. And this is a second filter that's available in with Taxonomy Manager, and you can read about that in the docs, which I'll point you to at the end of this presentation. And I've tagged each of these plants with a color. If I go back over to Vision, we can look at what the query looks like for colors. And for the example use case that I started us off with at the very beginning, what I want to find is not plants that are the same color, not plants that are sibling colors, but plants that are complementary choices for each plant based on shade. So I want to find, if I've got a dark plant, I want to find all the light plants. If I've got a light plant, I want to find all the dark plants. And this is a simple example of how you can encode a knowledge model into a taxonomy, but it can get much more complex. And it's all based on what you're trying to accomplish with your business and your content. So to run this query, I'll again look for plants, I'll return the names. In here, I want to return the complementary colors. To do this, I'll look for a SCOS concept, which, if the current resource has a color defined, and we do this to prevent null matches, is a grandchild of the resource's colors broader concept and is not a child of the same color as the resource. So the grandchild resource, we're going to look for the broader term's broader term, and this is a monohierarchical taxonomy. So I'm just going to get the first term in each one of those arrays because there's only one parent, and I'll look to see where they match that same grandparent in the parent document. And then I'll look for, use a similar query that I'll look for the parent terms of each one of those, and I'll look for a not matching the parent term. So they share a grandparent, but not a parent. These are cousin terms. And if I run this query, we'll see that we have for our, let's say, ryegrass, complementary plants in sage, contorted filbert, and hosta. And if I go back to ryegrass, this, of course, is red, which is in the dark shade of our color facets. And if I look for contorted filbert, that is ochre, which is in the light shade. And then hosta, of course, will also be in ochre, as will sage, because that's what we queried for. So that's how we can run a slightly more complex query. And that's how we can start to leverage the power of these knowledge models that we've encoded in the taxonomy in Studio. Okay, so that's a lot. As you would imagine, there are some docs, and I want to point you to those because there's a lot more you can do with this, and there's a lot that I covered quickly there. So first of all, you can get the Taxonomy Manager plugin on NPM. There are a series of guides on creating and setting up taxonomies on Sanity Exchange, and it's easiest to get to those through my profile on Sanity Exchange. You'll see a list of them. And then the Sanity Taxonomy Manager docs are at sanitytaxonomymanager.com, and you'll see instructions for setting up a taxonomy, for importing a taxonomy from a spreadsheet, as well as some best practices for creating taxonomies, and then, of course, pointers to resources on more expansive best practices for that. I have some articles and methods on creating and using taxonomy on my website. And for anyone listening or tuning in, please connect with me on LinkedIn, and please feel free to reach out if you have any client questions or projects that you're working on that you could use some help with at Andy@andyfitzgeraldconsulting.com. Thank you.